6C is about radians, and I'm getting criticised already for my R. There you go, you're happy now. Radians. Okay, so we're used to measuring angles in degrees. There is another unit of measurement, and it's got to do with our trig ratios, and that unit of measurement is 2 pi as a full circle. Okay, so 2 pi equals 360 degrees. Alright, so what's pi? 180. Alright, so it's 1/2. Alright, yes, pi is 3.14, thank you very much. But in terms of radians, pi is 180. I should have the little radian symbol. The little radian symbol is a little c. Okay, I don't know, because that's what the symbol is. Alright, it's just what it is. So 2 pi radians is 360 degrees. Pi radians is 180 degrees. So what's pi on 2? 90. Okay, so now you get the wonderful, wonderful idea of another exact values table, which is on page 278. Okay, which gives you the exact values in terms of radians. Okay, so if you're chasing pi on 2, the exact value for sine is 1. Okay, if you're chasing pi on 4, the exact value is root 2 on 2 for cos and sine. Alright, so that is pretty much all that is. It's the same deal. It still applies to the unit circle. Okay, so if I redraw another dodgy circle, 0, pi, 2 pi, pi on 2, 3 pi on 2. Okay, so everything else we just talked about in terms of the trig ratios and where they are, we're still A, S, T, C. Okay, they're all still positive in those quadrants. Okay, everything else still applies. It's just you need to get it into your head that instead of talking 360 degrees, 2 pi is a full circle. Okay, and then you're fractioning that to work out which quadrant you're in, and you go from there. The easiest way to do it, or the way I find easiest to do it, is to straight away go back to degrees. Alright, that's the way I do it. I'm not saying you guys should do it this way, but if I'm chasing pi on 6, I go 180 divided by 6, that's 30 degrees, so I'm chasing 30 degrees. Alright. If they're asking for 5 pi on 6, alright, you're actually around here coming back 5 pi on 6. Alright, you sort of go around 5/6 of that half a circle. Okay, so it's pretty much the same between 6b and 6c in terms of what they're asking you to do, but in a different form. In a different form of measurement, that's all. Alright. The only other thing they do ask you to do is to convert between them. Okay, so it's actually not that hard to do. It's not that hard to do. Alright, so we already know that pi in radians is 180 in degrees. So we can use that as a basis. Okay, so if we're chasing 1 degree, so if you're converting 2 degrees, let's do it this way, 2 degrees, what you need to do, okay, is do times by pi on 180. Okay, so if you're converting 2 degrees, you multiply by pi on 180. Okay, if you're converting 2 radians, what do you think you should do? Alright, I might have them the wrong way around. Yeah, I've got them the wrong way around. Swap them. I think. Hang on, my brain's broken. Let's do one, let's test it. Alright? Let's do one. So if we're asked in question 2a to convert pi on 5 to degrees. Okay? So if I do what I said here, which is wrong, alright, then we're going to end up with pi squared on 180 times 5, which is not going to be where we want to go, because we want to remove that pi. So if we actually multiply, so they're actually the wrong way round. Okay? So that's radians. That's degrees. So if we times by 180 over pi, the pi's will cancel, we end up with 180 on 5.
Radians is 180 over pi.
Dang it!
And This is pi over 180.
So I have got it the right way around.
Yes.
Okay, I'll start all over again. Scrap the video.
That's what the book says.
Okay, so I did have it the right way around first time. Okay. Alright, so let's go back to our original. This is degrees. This is radians. Alright, so if we're converting from radians to degrees, according to this, we do times by pi over 180. Which doesn't make sense in my head, but must be right. No, it can't be. It's wrong! Dang it!
Maybe you were on piece. Maybe you wrote down wrong.
No, I checked in the book.
Where's it say in the book?
In the remember box.
Yeah, to go to radians. Yeah, to go to radians.
Oh, I was going from.
Yeah, you're going from. Alright, let's write that again from the start. From, let's do both. From radians to degrees.
Can't see it.
Yeah, I know. Alright, so from radians to degrees. We need to multiply by 180 over pi. From degrees to radians, you multiply by pi over 180. Alright, now if we put that back into practice, where we're doing pi on 5, and we're converting from radians to degrees, which means we're multiplying by 180 over pi, you'll see that our pi's cancel. We end up with 180 over 5, which actually turns out to be 36 degrees. Right? If we're going the other way and we're saying, okay, if we've got the angle 27, let's do a different one. Let's do 49 degrees. This is question 6. So 49 degrees in terms of radians, okay, we're multiplying by pi over 180. Alright, which is 49 pi on 180, which of course you could simplify down, but I can't be bothered doing it. Alright, so you would simplify that down. Alright? Make sense? So, just to reiterate, from radians to degrees, multiplied by 180 on pi. From degrees to radians, multiplied by pi on 180. Okay? Guaranteed to be correct now.